going to take a look at the inverse of an exponential function. And the way we're going to do that is first looking at our Sierpinski triangle that we've seen before. We have a table below showing us that at the very beginning there is one black triangle. And so our output is one triangle. Then if we do one iteration, we have 3 black triangles as an output. 2 iterations is 9, 3 iterations is 27. So if we take a look at this model, we recognize that we are multiplying by 3 every time. So the type of sequence is geometric. And the function that can model this is f of x equals 3 to the x. This type of model is exponential. Looking back at the actual questions, I have these 2 answers swapped. Now we're to graph the function. If I are going to graph f of x, then I might build a table of values. However, we already have that table of values with our table up above. So at iteration 0, we had 1 triangle. At 1 iteration, 3 triangles. At 2 iterations, 9 triangles. Looks kind of like a parabola, except we know that we're multiplying by 3 each time. How do the domain and range of the function rule compare to the domain and range of the problem situation? So in the problem, we had actual triangles, and our domain starts off with 0 iterations, 1, 2, and so on. The range is the result. We had 1 triangle at the beginning, we had 3, 9, and so on. But with the function is a line, and it represents that we could have partial triangles or even negative triangles if I brought this all the way over. It's going to come right next to that x-axis. It's not actually going to cross since this is exponential. And the domain of an exponential is from negative infinity to infinity. The range is how far down we go. Well, we come down to 0, but we don't actually touch 0. It's kind of a rounded. So we've taken a look at a context of an exponential graph. Now let's continue that with looking at its inverse. Number 7 says, how many upward triangles are in the 10th iteration of the Sierpinski triangle? We could continue the pattern of the table, or we can use our function, f of 10. The 10th one is going to have 3 to the 10th power, and I would definitely want to grab a calculator at this point. There's going to be 59,049 triangles. Number 8, which iteration of the Sierpinski triangle has 531,441 upward triangles? So we are trying to figure out what x is when this whole answer is the 531,441. We can solve this by trial and error. I'm going to take 3 to the 9th power. Oh, that's not it. 3 to the 12th power. I'm typing something wrong. There, I got it exactly at 12. So 3 to the 12th gave me that answer. That tells me x is 12. That's doing this in reverse, where we want the number of triangles. We've been given the number of triangles, and we have to figure out the iteration. That's called an inverse process. And in the table down below, we have the same Sierpinski triangle table with its values. We're going to create the inverse by swapping the domain and the range. So the domain becomes the range. We will have 0, 1, 2, and 3. The range is going to become the domain, 1, 3, 9, and 27. We already have the graph here for the function 3 to the x. Now we're going to plot the ordered pairs that are in the inverse. Remember, they're just the ordered pairs that are on the left but switched. So now we have 1, 0, 3, 1, 9, and 2, 27, and 3. I'm going to go ahead and draw a line through those. We have our exponential, and this lower one is what we call a logarithmic. This happens to be a logarithm of x with a base of 3, it's a lowercase subscript. And if I were to draw the dotted diagonal line, which is my line of reflection, I can see that the graph of the original function is in fact a reflection over that line to give me the inverse function. Number 10, what type of function models this inverse? Well, it happens to be a logarithmic function, and in this case is the logarithm of x base 3. Number 11, the inverse of an exponential function is a log function and is written in the form f inverse of x equals the log of your base number of x. The graph of a function and its inverse function are reflections over the line y equals x. Number 13, how do the domain and the range of the function compare to the domain and the range of the function's inverse? Well, we had our original function. Our original function was f of x equaled 3 to the x. And the domain of this one is negative infinity to infinity. The range is from 0 to infinity. We did that on the prior page. So when we take the inverse function, which is f inverse of x equals the log of x base 3, the domain is going to be the domain or the range from before. The domain and range swap from function to inverse, of 0 to infinity. And the range is going to be from negative infinity to infinity. I can confirm that by looking back at our graph. For the inverse function, we have this going forever in the x direction to positive infinity. However, if we trace this back, what will happen is this logarithmic function will come down here and will come right next to the y-axis. It's actually not going to cross it. So it comes close to 0. The domain is from 0 to infinity. The range, on the other hand, since the y values are going forever down, y values go down to negative infinity, and then they come up slowly, and they're going to keep going up to positive infinity.